Hi, welcome. We are the JMU Shell Eco Marathon Strategy Team. The JMU Supermileage Team has been participating in the Shell Eco Marathon competition since the year 2018. Shell Eco Marathon is one of the world's leading student engineering competitions where STEM students from across the globe design, build, and operate some of the world's most efficient vehicles. We identified that the enterprise had no strategy to drive around the track, nor the platform to analyze the performance of the fuel-efficient vehicle analytically. Our project entails delivering a mathematical model that characterizes the vehicle and helps us make data-driven design decisions by simulating the vehicle around a given track to analyze its performance resourcefully through Simulink. This project ultimately has helped us all get an understanding of model-based engineering and the value it brings to us and future JMU Supermileage teams. I have been working extensively as a project manager and also programming our electronic fuel-injected system for optimal performance in different operating conditions.
In the internal combustion engine Shell Eco Marathon prototype competition, teams compete to create the most fuel-efficient vehicles in an effort to understand what changes can be made to the design of an internal combustion engine. This creates value through the use of innovative technologies such as fuel injection conversion, converting a carbureted engine into fuel injection, allows for greater control over air-fuel ratios and a feedback loop into the ECU, which can then lead to parameters changed based on performance. My contributions to the team have emphasized the design of a new throttle body, something that has plagued the previous teams with problems and allowed us to make huge steps forward. The throttle body is a very complex system, and I was able to get the subcomponents to work in harmony with one another. Cars are also very complex systems that have evolved a lot over the last century. However, unlike the throttle body, they are not perfect machines. Most internal combustion engines have an average thermal efficiency of 40%. Meaning that the other 60% is wasted and the fossil fuels used to generate that cannot be captured. This creates wasted emissions that are subsequently released into the environment and pollute everything around us. As we may know, the pollution through engine emissions lead to depletion of the ozone layer, and this is something that is very sensitive to change and takes a long time to regenerate, time that we may not have. With rising sea levels and changing weather patterns, we must act fast to reverse these effects before it reaches the point of no return. While looking at alternative sources of energy of vehicle propulsion, we must also work with what we have now and make an effort to reduce emissions. This can be done most simply and effectively through driving habits. Our team has implemented driving strategies that promote only the use of the engine when the vehicle's potential energy needs to be increased, for example, when traveling up a hill, and cuts off the engine when kinetic energy can be used.
These past 2 years, we've been working parallel with the vehicle and model to ensure accuracy. As the model architect engineer, I've been taking lead on the mathematical model and the whole construction behind it. With the model, we've been taking physical components and specifications from the physical vehicle behind me into the analytical realm. The subsystems covered within the model are the chassis and drivetrain subsystems. The way the model works is we've been identifying inputs, establishing connections to appropriate parts, and using key blocks and functions to simulate our outputs. Our outputs being engine power, fuel efficiency, and vehicle speed, all with respect to any racetrack we wish to run the vehicle on. The way we did engineering analysis behind that was using functional block diagram to ensure the structure of the model and how it will be visualized. We chose Simulink because we had previous exposure to MATLAB and Simulink in our previous classes, and because it had the necessary tools and add-ons to translate the vehicle in any analytical platform.
The mathematical model that our team has built will be a tool for future JMU Shell Eco Marathon teams to use. The model is meant to be adaptable, so as teams change the design of the car, the model can also evolve. It will help the enterprise by showing the best driving strategy to maximize fuel economy and will encourage data-driven design changes. On a broader scale, our mission goes beyond JMU. We are part of the Shell Eco Marathon, where the focus is to create more fuel-efficient vehicles. It shows how change is possible and challenges students to go beyond the classroom with their designs, to think of the bigger picture or the carbon footprint and the life cycle of what they are making. This mindset will influence our future work by taking strides to create better, more environmentally friendly innovations. For the team, I am the chassis engineer. My role has been focused on completing the body of the vehicle and ensuring that all aspects are safe for the driver. Through this, I have become a main fabricator of the group by machining customized parts like the throttle body valve designed by Francis, the drive shaft designed by Jordan, and the gearbox designed by a previous team. The drive shaft in particular was an incredible feat, as it went through many design iterations and was machined in stages to best evolve with drivetrain mechanics. I have also designed and fabricated the nose cone, as well as built supporting material for the chassis of the vehicle.
As we move towards the end of the semester, there are some tasks that have yet to be finished. One of them involves the documentation and storing of all research, testing, and other important information gathered since the start of this project. As a component of the JMU Supermileage enterprise, we have the ability to not only share our documents into the Google Docs folder, but we can also use previous teams' folders as references. Therefore, by leaving behind our own documents, it gives future teams the opportunity to understand what we've done during our 2 years working in the capstone project. It also allows them to not repeat previous mistakes made and to use procedures that we created in case new problems come up during the progress. The other task involves the transitioning of the current junior team into the senior team position. Through mentorship in each of our roles, we've given the junior team the knowledge needed to continue what's left off after we graduate. This will also give them an opportunity to take full control of the vehicle and perform any changes for next year's Shell Eco Marathon competition. They will also work towards completing the application process and submitting technical documentations required for the competition. As a lead in the electrical system, I've been working on refining the system that gives power to the EFI kit and the electrical starter. I created the electrical diagrams to assist the members in understanding the wiring schematics and as a requirement for the competition. I also had a role in ensuring the fuel pressure system is fully pressurized to ensure proper functionality. Previous teams' designs have failed to ensure an airtight seal in the system, which affects fuel from injecting properly into the engine. By validating the design through a variety of tests, I was able to create an adapter that connects the fuel container with the rest of the system. This design, along with some minor adjustments, eliminates all signs of air leakage in the system.
I'm the lead on the drivetrain system, where I designed a new drive shaft for the engine to accommodate the starter circuit and drive gear. The design was then sent to the machine shop where Jordan Capel fabricated it. Alongside the drivetrain design and fabrication, I played a large role in prepping the engine to go into the car and troubleshooting fuel injection conversion issues. Many unforeseen nuances of the engine were discovered and solutions were found and implemented. You have been hearing a lot about all the things we have been doing, but nothing about what you can be doing. The team has a dream of sending every member to the competition every year and drastically innovating with the best tools and resources possible. If you believe in the mission we pursue, students and future students involved, consider giving a donation to the foundation, the link shown right here. If you don't have money, don't fret. There are still things that you can do. Ride a bike, walk, carpool, or ride the bus to decrease your personal fuel consumption. Check out this resource for ways to decrease your carbon footprint. The last thing you can do is follow us on social media.